Hi, welcome to AsapCALCULUS, in which we explain what your textbook can't. Today, we'll be talking about volumes, specifically volumes of revolution in which a plane figure is revolved about an axis to generate a volume considering the region between a continuous function and the axis from x equals a to x equals b. Today in this video, we will be using the disk and washer method to find the volume of a solid, as well as using a solid with a known cross-section if the cross-sections were to be taken perpendicular to the x-axis. For the disk method, we will be using a plane bounded by the x and y axes, as well as x equals 5 and y equals 4. This plane will then be revolved around the y-axis to form a solid of revolution. In order to find the volume, you must first consider the area. Since the face of our solid is a circle, our area function would be pi r squared. Using an integral from a to b, we will integrate the function to find the volume. In this case, we will integrate 25 pi dy from y equals 0 to y equals 4. After integrating, we will be getting pi 25y from 0 to 4, and using the fundamental theorem of calculus, we will solve 100 pi minus 0 to get 100 pi as our volume.
Say SpongeBob wants to find the volume of the inside of his net. His net is a parabola with the equation y equals plus or minus the square root of x, and his net is 9 inches long when he measures the farthest point from the open end of the net. The graph would look like this and would be bound by the x-axis and x equals 9, and would be revolved around the x-axis to make this shape. Since the area of a circle is pi r squared, and since the radius would be the square root of x when we find the volume of the net, it would be the area under square root of x from 0 to 9 put into the equation for the area of a circle as r. Therefore, the integral is pi times the integral from 0 to 9 of the square root of x squared dx, which is then pi times the integral from 0 to 9 x dx, which would be pi times x squared over 2 from 0 to 9 after it is integrated, and using the first fundamental theorem of calculus, pi times 9 squared over 2 minus 0 equals 81 over 2 pi, meaning the volume of jellyfish SpongeBob can fit in his net is 81 pi over 2 inches cubed.
When your plane is not bounded by the axis it will be revolving around, you will be utilizing the washer method. With this example, we will be using the area between y equals 2 and y equals 4, as well as the y-axis and x equals 4. It will then be revolved around the x-axis. So, as you can see, a solid with an open area in the center will be formed. Using the area function pi r squared, we will be finding the volume by integrating a function subtracting the area of the big radius with the area of the smaller radius, using big R and little r. So our function will look like pi times the integral from 0 to 4 of 4 squared minus 2 squared dx. We will then get pi times the integral of 12 dx from 0 to 4, and after integrating, we will be getting pi times 12x. Using the fundamental theorem of calculus, we will then subtract 0 from 48 pi to get 48 pi as our volume. Let's say we wanted to know the volume of a lampshade. For this example, we will be using the areas between functions y equals x squared and y equals x minus 2 squared, bounded by the x-axis and y equals 16. This will then be revolved around x equals 6. Because it is revolving vertically, our functions must be set in terms of y. So this will change from y equals x squared to x equals the square root of y, and y equals x minus 2 squared to x equals the square root of y plus 2. We will solve by multiplying pi and the integral from 0 to 16 of 6 minus square root of y squared minus 6 minus square root of y minus 2 squared dy. After multiplying everything out and simplifying, we will then get pi times the integral from 0 to 16 of 20 minus 4 times the square root of y dy. After integrating, we will then get pi times 20y minus 4 times 2y to the 3 halves over 3. After using the fundamental theorem of calculus, we will then find that our volume equals 448 pi over 3.
For our cross-section example, we will use the equation x equals plus or minus the square root of y, which will be bound by x equals 7 and will be perpendicular to the y-axis. For a cross-section, it is similar to revolving around an axis, but instead of using the area of a circle, pi r squared, and plugging the equation in as r, we use the area of other shapes, and in this example, we will use a square. Since the area of a square is s squared, and in our example s equals plus or minus the square root of y, the integral will be the integral from 0 to 7 of plus or minus the square root of y squared dy, which can be simplified to the integral from 0 to 7 of y dy, which, once integrated, is y squared over 2 from 0 to 7, and using the first fundamental theorem of calculus, 7 squared over 2 minus 0 squared over 2 equals 49 over 2, which would be the area of our cross-section.